Buenos días, bienvenidos a nuestro webinar. Mi nombre es Cristian Alfaro, soy gerente de ventas de Sistemas para el mercado de habla hispana de Latinoamérica y vamos a hablar hoy día, junto a nuestro partner Solaer Ingeniería, sobre nuestras principales soluciones en el campo de electromagnetismo. Antes de comenzar, voy a apagar la cámara por un tema de delay, muy rápido, ahí. Antes de comenzar, tengo algunos mensajes relacionados a la logística de este webinar. Todos los participantes tienen su micrófono apagado. Las preguntas o consultas las pueden realizar a través del chat de la plataforma, como se muestra en el slide. Los últimos 10 minutos de la presentación serán dedicados a responder vuestras preguntas. Y adicionalmente, este webinar será grabado y compartido con todos los asistentes. Bueno, esta es la agenda que vamos a revisar hoy día, muy rápidamente. Quiero aprovechar de presentar quienes nos acompañan en esta presentación. Ricardo Ramos, que es socio y gerente general de Solaer Ingeniería. Mencionar que Solaer es partner y representante de Dassault Systèmes en la región por ya más de 12 años. Uno de nuestros principales partners en todos los temas de simulación en particular. También nos acompañará Rafael Scuderi, de Dassault Systèmes. Él es consultor senior, especialista en análisis y soluciones electromagnéticas. Para comenzar, les voy a compartir algunos hitos sobre nuestra compañía, Dassault Systèmes. Dassault es una empresa francesa con más de 40 años en la industria del software. Dassault nace en la década de los 80 de un spin-off de Dassault Aviación y desde esa época hemos sido un catalizador y habilitador de tecnología en las diferentes transformaciones industriales. Somos una empresa impulsada por un propósito, como dice el primer punto arriba en el slide. Pensamos en el progreso y la innovación en términos de equilibrio e impacto. Nosotros creemos que el desarrollo y la innovación es una prioridad necesaria y de esta forma poder armonizar la tecnología, la ciencia y el arte desde un punto de vista tecnológico. Ya somos más de 20.000 personas de 140 diferentes nacionalidades alrededor del mundo. Compartimos los mismos valores y la pasión por la innovación. Contamos con un gran equipo de investigación y desarrollo que trabaja en forma conectada en 69 diferentes laboratorios alrededor del mundo. Tenemos presencia en los 5 continentes, en particular en Latinoamérica estamos en un plan de expansión. Tenemos oficinas directas como Dassault en México, en Brasil, en Colombia y en Chile, y parte de esta expansión que lleva ya un par de años es seguir teniendo presencia más fuerte en forma local. Sin embargo, para nosotros es muy relevante tener socios comerciales o partners. Por este motivo contamos con un ecosistema de más de 12.600 partners seleccionados con los cuales trabajamos en diferentes proyectos con diferentes capacidades, lo que nos da mayor cobertura y presencia a nivel mundial y particularmente en Latinoamérica. Tenemos una importante y relevante participación de mercado en 11 diferentes industrias con más de 270.000 clientes alrededor del mundo. Somos la segunda empresa de software más grande en Europa. Y contamos con programas especiales para emprendedores o startups con el objeto de apoyarlos en sus inicios. Este slide resume nuestro portafolio y las industrias donde Dassault tiene presencia. En el lado izquierdo de su pantalla pueden apreciar lo que nosotros denominamos plataforma 3D Experience, con nuestras 13 brands distribuida en 4 bloques alrededor de nuestra plataforma. Una de estas brands es SIMULIA, donde se encuentra la solución CST Studio, que es la que vamos a profundizar más adelante. En el lado derecho del slide se pueden apreciar las industrias donde Dassault Systèmes tiene presencia y con los cuales hace desarrollo a medida en cada una de ellas. Y por último, mi última parte de la presentación, es una rápida mirada a los principales clientes que tenemos a nivel mundial por cada una de las industrias. Es un resumen de estos clientes quienes nos han autorizado a poder hacer público su nombre y su logo. A continuación, voy a dejar a Ricardo Ramos, socio y gerente general de Solaer Ingeniería, para que él continúe con la presentación. Ricardo, adelante, acaba tu slide.
Muchas gracias, Cristian. Buenos días a todos. Bueno, Solaer Ingeniería, como Cristian anticipó, tiene ya más de 12 años trabajando con Dassault. La empresa está estructurada en dos verticales distintas. Por un lado tenemos todo lo asociado a software y por otro lado todo lo asociado a servicios. Dentro de las plataformas de software que nosotros comercializamos se encuentra la división de Simulia, que es toda la que está asociada a los productos de simulación numérica computacional, y una de las líneas que tiene es la línea de electromagnetismo, que es en donde hoy nos ubicamos para el webinar de hoy. El área de servicios trabaja esencialmente como una empresa de servicios de ingeniería y de simulación también. Entonces, el valor adicional que tenemos con esto es que nosotros vendemos el software que usamos a las industrias que conocemos. Una más, por favor, Cristian. Tenemos presencia en distintos países de la región, en algunas en forma directa, o sea, son empresas en las cuales tenemos capital accionario, o otros, como el caso de Perú, en las que son socios estratégicos con convenios de largo plazo para el desarrollo tanto del sector de servicios como del sector de software. En total estamos hablando de una estructura de 70 profesionales, de los cuales 50 de ellos se encuentran en Argentina. Una más, por favor. Dentro de los clientes que tenemos, ustedes van a encontrar nombres conocidos, sobre todo para los que son de Argentina en este momento, pero algunas de las empresas van a ver que son empresas que tienen un alcance global, como el caso de Tenaris, y nos ubicamos en distintas áreas, tanto de lo que es energía, aeroespacio y defensa, movilidad y transporte, y en la parte de construcción también. Una más, por favor. No es la intención del día de hoy hablar del licenciamiento, sino que el mensaje que yo les quiero transmitir con esto es que la oferta de licencias está customizada para los distintos sectores que se encuentran hoy presentes en el webinar. Hay licencias que están preparadas para estudiantes, sin costos. Hay licencias que están preparadas para dar clases, licencias de teaching. Hay licencias de investigación y licencias comerciales. Nuestra intención es, luego del webinar, entrar en contacto con cada uno de ustedes para ver en su sector correspondiente cuál es la licencia que mejor se podría ajustar o discutir sobre qué tipo de colaboración podríamos tener. Estamos muy abiertos a lo que son los trabajos de colaboración y sobre todo el relacionamiento con la academia. Una más, por favor. También dentro de la oferta de Dassault se encuentran cursos online, que son cursos de autoentrenamiento en su gran mayoría, que son muy recomendables para acelerar la curva de aprendizaje y la adopción de nuevas tecnologías, más allá de que puedan ser complementados con cursos online, con un instructor o cursos presenciales eventualmente. Una más, por favor. Bien, dicho esto, vamos a dar el paso a la presentación, al núcleo de la presentación, que es la presentación de Rafael. Antes de hacer el cambio a inglés, quisiera destacar el background de Rafael, que tiene una amplia formación académica, pero también tiene una amplia trayectoria industrial. Entonces, hoy tenemos la oportunidad de estar hablando con una persona que conoce en detalle la física de lo que va a estar mostrando y la aplicación industrial que tiene. ¿Ok? Now, Rafael, we can switch to English. The show is yours.
Thank you very much, Ricardo. Thanks, Christian, for the introduction, and good morning, everybody. Thanks for joining this webinar today on SIMULIA CST Studio Suite. What we will see today with me as a technical person is an introduction, a presentation on the capability on electromagnetic simulation that SIMULIA CST Studio Suite offers. And I'll now switch off my camera so that we can carry on with complex systems, increasing production rates efficiently, support can help on cutting down all those costs. And of course, more data bandwidth, number of antennas on the same platform, so EMC, EMI problems, interference, dependence on automated flight. You know, we are talking a lot about automated flight capabilities, so communication will certainly be critical also from this perspective. Lightweight composite materials. Of course, as you know, whenever we use metal, everything is very nicely shielded, but when it comes to composite materials, then, you know, there can be a lot of EMC, EMI problems, and that's why taking care about this problem is crucial and important. In this context, as we have seen all those potential source of threats, the 3D Experience platform represents the right solution to give an answer to all the aforementioned challenges. And because it offers a unique collaborative environment for connecting different working teams and professionals. This improves the efficiency of the whole process, allowing to drastically cutting down the time to market and the related cost. So reduce the physical testing, increase the numerical simulation. On top of that, the probability of failure will also be drastically reduced. And in this presentation, we will focus, of course, more on the electromagnetic solution offered by SIMULIA CST Studio Suite, in synergy with the 3D Experience platform, thanks to the Power by link that is already in place. Complex systems such as satellites, aircraft, other different platforms, of course, need to be certified. And this is a very important point for manufacturing companies. The certification process typically implies physical testing activities, which can take time and are certainly expensive. The probability of failure is quite high, so we can end up having so many iterations in our certification process. And building what we call a virtual twin of the real system and predicting the behavior from the electromagnetic perspective represents for sure a solution extensively used already to reduce physical testing activities and therefore to reduce the time to market. This has a massive reduction on the whole activities cost, and that's what we call a virtual twin, so a high fidelity model for predicting the behavior of the real model. Some examples of what can be obtained running a simulation with CST Studio Suite are reported in this slide. So what we can see is that we can easily get near field, far field distribution, analysis of antenna gain, impedance matching and optimization, beamforming, interaction interference with other electrical and electronic systems, susceptibility of critical systems to EM radiation sources, cellular and Wi-Fi antenna placement and coverage, SAR, specific absorption rate ratings, and also thermo-electrically coupled solution. So not just EM, but also thermal simulation is available within CST Studio Suite. And that was a very brief and general introduction on the capabilities of CST Studio Suite. But now let's dive a little bit on electromagnetic simulation for satellite applications. I'm talking about satellites, of course. We need to consider the enormous amount of satellites orbiting around the Earth and the number of aircraft, aerial vehicle in general that are in the sky at this moment. if you look at those numbers, you can easily, figure out the massive amount of platforms we are talking about. And communication play an extremely important role, especially for supporting autonomous flight capabilities. So, I mean, no questions here. A good analysis, a good design, including all the electromagnetic phenomena, is certainly needed. If we consider, for example, a satellite, there are several questions we need to get an answer for. And typically, if you look at here, is the space available to route cables from the system to the antennas? How do we reduce physical testing to the minimum? Will the satellite structure affect antenna performance? Will the communication systems interfere with each other? Will the antennas work in their proposed locations? Those are all very valid, very important points we need to get an answer for. And the answer that we can get, it's of course something that comes from measurements, so from physical testing, and for sure, this is something that we have to do at the end of our process, at least. However, we can already have an answer, a very reliable and accurate answer in a very early stage, in an efficient and costly effective manner. And the way to do it is virtual prototyping. This is the solution already adopted, by the way, by big players all around the world for limiting physical testing activities and getting accurate and quick answer. You can imagine that, running a simulation on a computer is much easier than going there, have, for example, your anechoic chamber with all the manpower needed and hardware and time, okay? And then, of course, when you do measurements, it's something that still requires a lot of manpower, and, humans, we work, I don't know, something like 8 hours per day, 5 days a week. A machine works 7/24. So you can easily imagine that there is a huge advantage on simulation. And when it comes to virtual prototyping, SIMULIA offers the most complete solver technology for electromagnetic simulations. No questions about that. You've got a massive portfolio of solver, of numerical solution of the Maxwell equation, different tools for different application. So you always have the right tool at the right moment for tackling different kind and family of problems. The picture in this slide shows, for example, how the communication antenna reflector can be affected by the GPS antenna radiation field. And this is something, very interesting and typical. And together with that, we can obtain several different outputs, such as induced currents, near field and far field, calculated and visualized within CST Studio Suite. Another important device are antenna arrays. The antenna arrays are a well-established technological solution in space application, as they allow to achieve high antenna gain, beamforming, beam steering, and things like that. And CST Studio Suite provides dedicated tools for the analysis of arrays and synthesis. Maybe we can spend a few more words later on the array task. Another important point is the verification of potential interference issues that can happen when different transceivers are installed on the same platforms. So whether we have a transmitter or a receiver, and we can potentially have many of them, all those devices, they need to coexist perhaps in a fairly small volume, and they need to operate without disturbing each other. And in this regard, CST Studio Suite offers all the needed capabilities to predict the potential interference among systems. Performing this kind of simulation, different radios, transmitter, receivers can be defined, including all their features such as transmitted power, sensitivity, harmonics, and so forth, so on. And this is all implemented in what we call interference task. And as you can see in here, we can get what we call the violation matrix, where, you know, we check each device with each other whether there is a potential source of interference or not. Okay, with this very easy way to immediately visualize some potential problem with color, green, yellow, or red. Thanks to the complete technology that CST Studio Suite offers, the results obtained from the electromagnetic simulation can be coupled with the thermal analysis capabilities. And in this slide, we can see how a PCB can be imported into CST and analyzed, obtaining a good matching with measurements. Okay, so not just EM simulation, but also thermal. And the typical workflow is to start from a CAD and then preparation of the CAD as well, just to make it suitable for the EM simulation. And after that, we exploit the results from the EM simulation to get temperature on our device. And we can, of course, cross-check with measurements, and we can use that information to understand whether there are some possible source of breakdown of the device or overheating here and there. And for doing that, there is, of course, dedicated solvers. There are more than one, of course. In my opinion, the most complete solver that we have in CST is the conjugate heat transfer, which includes conduction, convection, and radiation effect, together with an accurate material modeling and characterization that can be included in the simulation to get accurate results, also from a thermal point of view. Let's talk now a little bit about communication systems in aircraft, another crucial point, very, very important. As for the satellite, the sky is becoming every day crowdier with so many aerial vehicles and very demanding communication requirements. Therefore, having reliable communication is crucial for a safe and efficient operation of aircraft. You can imagine, you know, all the possible new requirements, all the needs that are becoming more and more demanding because of the number of platforms, because of the variety of things and services we want to provide our passengers with. So certainly, as a reliable communication system is extremely important. Small aircraft that have to be detected as well. I mean, even radar signature is very, very important. So not just the active parts, so not just antenna performance, pattern and communication, but even the detection of aircraft is very, very critical. So radar cross-section, in other words, and the RCS calculation is something that we can easily do using CST. We can maybe have a look specifically at it later on. Talking about communication system, we all agree that the antenna is one of the fundamental components. So let's explore the antenna element design capabilities in CST and Antenna-Magus. CST Studio Suite, it usually is kind of supported also by Antenna-Magus, which is a separate tool perfectly compatible with CST that is typically used for early stage analysis and design. For the following exploration on antenna Magus, I will take a blade antenna for VHF communication as an example for our discussion. The blade antenna is a typical aircraft antenna that offers omnidirectional far-field pattern on the azimuth plane, and it has a suitable aerodynamic properties. Also, lightning and P-static protection can be integrated on the radome of the blade antenna, so it's a very nice case that we can use. So what's Antenna Magus? Antenna Magus, it's a software tool that works together in conjunction with CST, and it's conceived because typically antenna design requires, of course, expertise, requires person skilled on the EM side. However, using Antenna Magus, the design and analysis part can be really accelerated, and all the modeling process can benefit of Antenna Magus. And that's simply because it increases the efficiency by helping the engineer to make a more informed choice of the antenna element and obtain a good starting design. So you don't need to start from scratch. You can use the Antenna Magus library for having already a starting point. So from a conceptual point of view, that's the typical Antenna Magus workflow. So we start from a specification, and the specification can be simply, all right, I need an antenna, GPS antenna that works in L1 band with this far-field pattern, and from there we can already find a good technological solution within the Antenna Magus library. So first of all, we go there. There are more than 370 different antenna solutions. So we can choose the closest solution. We can tweak a little bit the design, the model, all the parameters of the structure. We can evaluate the performance in terms of return loss, so S11, in terms of far-field pattern. If we are happy with that, then we can go to CST and refine the design that we just did with Antenna Magus. And of course, then we can use a full 3D simulation, using a solver for the solution of the Maxwell equation, a full-way solver in a 3D domain. If we are not happy with that, we can go back into the process at any stage, actually, and refine our design with Antenna Magus, and then again and again and again in a iterative way until we are satisfied with the performance that we get. And the nice part is that the model that we get from Antenna Magus is fully parameterized. So for example, if we are talking about a dipole antenna, just for argument's sake, the length of the dipole would be a parameter, so we can make it shorter or longer, just for example, for tweaking the resonance frequency pattern and so forth, so on. How does it work? So we have, as I mentioned, the specification chooser that aids the user in selecting an appropriate standard specification or defining a new specification. As I'm interested in this case in aircraft antennas, I'll select first aeronautical specification, and then I can choose between airborne and base station. I will go for airborne, of course, and that opens a list of specifications from which I can select VHS communication. So as you can see in here, I haven't made any initial hypothesis or any constraint at the very beginning. I'm just saying I need an antenna for aeronautical application, airborne, and I'm just choosing basically the operating frequency and band. And thanks to the specification chooser, I can already see several possible options for an antenna that satisfies my requirement. And in fact, on the left-hand side, we can see the specification is already selected for me. Then also a number of keywords are there. And then from the first row on the right-hand side, I will select the blade antenna, which is here. That's all. I already got a good technological solution for my antenna. And this solution is ready to be exported into CST. And the reason why I'm going to CST is, of course, because I get higher accuracy, because I will use a full wave method, time domain, frequency domain, whatever it's suitable for this particular model. And the model is actually fully parameterized. As you can see in this little list here, you can see the width, the tab width, tab top width, and so far so on. So all the parameters that describe the geometries are available here. So just changing a number, I can modify the antenna geometry. And this is very, very useful, especially if I want to optimize my design using the optimizers that are available in CST. Genetic optimizing algorithm, particle swarm optimization, and so forth, so on. You've got plenty of these tools into CST. We already mentioned about the importance of array antennas. So let's explore a little bit the antenna array design capabilities of CST Studio Suite, and in particular, the CST Studio Suite array task. In this example, an aircraft hosts a couple of antenna arrays for SATCOM and radar applications. These kind of antennas can be mechanically or electronically steerable. So using the array task, it's very, very it's quite well-established solution, I would say, in the aeronautical application and aerospace and defense market. When it comes to constructing and analyzing the antenna arrays, the array task is the best tool for the job. With it, we can define the physical layout and the excitation. So for example, we can say this is going to be 20 by 20 elements array, excited with a certain tapering, with a certain amplitude and phase distribution for having been steering and beamforming. For example, here there is a specific tapered distribution of the amplitude values to reduce the side lobe level, which can help to suppress interference with other satellite links. Okay, of course, the requirement and the final goal can be different, but the main message is that we have all the tools that we need to have the maximum flexibility and to always get an answer to our question, to our challenge. Once the physical layout as well as excitations are defined, then we can choose which kind of project we want to create. And we can create a unit cell project, which is suitable whenever we want to analyze an infinite array, including the mutual coupling effect, or we can use a full array simulation approach. In that case, we create the finite full array, 10 by 10, for example, and then we simulate it with, let's say, a brute force approach. When we use a unit cell approach, then we can calculate what we call an active input impedance, or active element pattern, if you liked, or active return loss also, because from the input impedance we can calculate the level of matching for the array, and we can calculate also the shape of the pattern. When we talk about active element pattern and active element impedance, we are including the fact that we are scanning the observation angle. And as you can see here, we have a map for different theta and different phi angles for a single frequency, okay? And that's because when we scan, when we want to steer the main beam toward a certain direction, we are basically changing the excitation condition. Changing the excitation condition implies that the active input impedance will change, and also, of course, the far field pattern also will be influenced by the different excitation set. And of course, scan blindness is one of the most important things we need to observe for an array. And that was for what we call a unit cell approach. So each of these three methods has its own advantages and drawbacks, but they are all useful and valid way to excite a full finite array. And so finally, let's discuss a little bit about antenna placement analysis and optimization capabilities in CST Studio Suite. As we can see from this slide, on an aircraft, there can be a huge amount of antennas for communication, navigation, and detection. And the antennas operate over a wide range of frequencies, as I'm going to explain in a moment. As you can see here, from the low frequency to the extremely high frequency bandwidth, we can have several devices that need to coexist and work properly together. And of course, this can be a source of potential problems, especially when it comes to interference. But before that, we can, from this picture, I think we can already appreciate how important it is to have a complete technology like CST Studio Suite. And that simply because different antennas, different applications, different shape, material characterization, frequency, of course, so wavelength and size in terms of wavelength require a different solver for different model. And as we can see from this slide, we can use time domain for small, medium size problems. We can use the integral solver for medium, big size problems. And after a certain point, even a single solver won't be enough. Of course, with CST Studio Suite, we can exploit the hardware acceleration. We can exploit GPU, graphical process units. It's all true. However, as you can imagine, will come the moment when an antenna or any kind of structure can be simulated with a single solver, and that's why our unique solution of a hybrid solver can be, the right key to resolve this sort of problem. Okay, so just to give you some real example, with a transient solver, for example, we can simulate the antenna with all its details, and then these can be combined with another solver to handle the electrically large part. And this is the typical antenna placement problem, where we have an antenna placed on a large platform. So the antenna will be solved with a time domain, frequency domain, or integral solver, while the platform can be solved, for example, with an asymptotic solver. This is extremely important. We offer unidirectional and also bidirectional hybrid approach. Unidirectional typically it's sufficient in many cases, but when this is not sufficient, then the bidirectional hybrid solver is available for you. And from this slide, we can easily understand the effect and the importance of taking into account the effect of the platform on the antenna. Of course, at the very early stage of our design and analysis, we can analyze the antenna behavior in free space. Sure, this is a very nice starting point, very important, we have to do it. And you can see on the left-hand side how nice and smooth the pattern for the blade antenna is. It's the typical donut that you can expect from such a kind of antenna. While when we install the antenna on the aircraft, which is not anymore an ideal ground plane like on the left-hand side, which is a free space antenna with an infinite ideal ground plane. In that case, the installed antenna performance will change a lot. And as you can see here, there is a lot of ripple. The shape of the far field pattern is not anymore, smooth, like for the case of the antenna, where of course the ground plane is ideal. It's a finite ground plane, not infinite. It's a finite ground plane, but it's ideal. Okay, while the real aircraft will significantly change the pattern. So it's very important that we include the real structure and we simulate the real problem. And the effects are seen not only on the far field pattern, but also on the return loss. So potentially we can have some source of mismatch simply because we have the effect of the platform compared with the ideal ground plane. Okay, so all those considerations are very, very important. Something that we can only get with the simulation. So, for example, the distribution of currents. This is something that we can see with measurements. Just to provide you something unique, a unique output of simulation. So when the antenna radiates, surface currents are induced on the metallic part of the aircraft. The whole aircraft essentially becomes an antenna, and so the antenna pattern will change, especially for VHF application. The aircraft itself becomes the ground for the blade antenna, so the aircraft geometry has a strong influence on that, for those frequencies especially. The level of impact on the pattern depends on shape, position, frequency, of course, and so forth, so on. But we can expect, something important even from the platform. Finally, in this investigation, we consider the installed performance of a SATCOM array. For this, a hybrid transient asymptotic solution is used. Transient solver, in this case, is used for analyzing the detail of the array, including the radome, while the asymptotic solver is used for the platform, because the aircraft is electrically huge at the SATCOM frequency, so 14.1 gigahertz pretty much. We can run a parameter sweep, we can change the array scan angle and check for any direction where the aircraft geometry affects the main beam and the side lobe levels. Those are all things that we can do with our hybrid approach. And another maybe important and interesting aspect is to check whether the radome is affecting the antenna performance. In this particular case, for this particular frequency, the radome, which is designed for the purpose, it's actually fairly transparent, as you can see. So there is no much difference in terms of pattern. What we expect is that when we move out from the frequency at which this is optimized, the transparency will become worse and worse until the performance won't be acceptable anymore. Last but not least, especially for quick antenna placement analysis, I would like to present to you our capability on calculating what we call the field of view. The field of view provides a quick and easy answer to see the directions where the airplane fuselage blocks the antenna propagation. So it's really a mechanical blockage of the structure. As shown on the plot on the bottom, based on θ and phi angles, the directions where the aircraft body is blocking the antenna can be identified. The typical way to overcome some undesired blockage effect is just moving the antenna and placing it somewhere else. Radar cross-section, as I mentioned, also the properties of a platform to be detected is very, very important. We need to consider that. Of course, there are measurement facilities also for RCS, but again, expensive, time-consuming, not so efficient like a simulation. And we can calculate the monostatic RCS, bistatic RCS, high-resolution range profiles, and also inverse synthetic aperture radar image like we can see here for the aircraft. Okay, this is all possible with CST. Last topic for today, let's explore a little bit about some land-based and microwave communication. And in this regard, I'd like to talk about 5G. The 5G technology, very topical in these days, offers multiple opportunities for different players. Network providers, chip manufacturers, device manufacturers, and all the people and companies involved on the classical outdoor network for our smartphone. All those kind of things are the typical 5G application that everybody can imagine. But 5G is not only that, it's actually much more. It is the driver to realize connected factory, for example, where it is necessary to properly design indoor networks. Antenna suppliers have to solve different, tasks. They have so many challenges, performance, for example, for array antennas, for coverage, because these antennas, they have to perform well, even installed on the equipment, and ensure network coverage in the factory. Smart devices, on the other hand, needs to work properly, and we have to make sure that electromagnetic field exposure is below regulatory maximum. So on one side, we have a strong requirement on coverage. We would like to have, some nice field distribution everywhere, so some good signal strength, but on the other hand, we don't want the field to be too high simply because of a safety of workers, of people that are walking around. And of course, this is something that we can achieve, calculate, refine, and design using CST Studio Suite. So network coverage, antenna placement, smart device, performance, electronics, array design, and dosimetry. And dosimetry means exactly, we will spend a few words on that, but means exactly, the amount of field that can become also temperature due to the electromagnetic radiation. Moving on to even larger simulations, such as propagation modeling inside the factory, a dedicated solution is needed. And with the emerging of 5G technologies, the need to be able to quickly and accurately model propagation is becoming extremely important. CST Studio Suite offers a dedicated solution for this type of analysis using a geometrical optics approach that provides the right trade-off between speed and accuracy. As I was saying, in order to improve coverage throughout the factory, we can of course add more antennas, more powers, more devices, more transmitters here and there, but on the other hand, how can we ensure that the total electromagnetic field exposure is below regulatory maximum? So we need to follow, of course, regulations, and the way to check it is to run a particular analysis that is available in CST Studio Suite, which will help us to calculate the dosimetry. And talking about dosimetry, I must mention that CST provides the most complete library of biomodels. We really represent the state-of-the-art technology when it comes to bio application, because in addition to the geometrical description of the body, we need to also use the right material properties, which are accurate and validated. And CST Studio Suite Material Library contains many different human tissue properties with electromagnetic, thermal, and mechanical properties. This is something that it's included in what we call the CST voxel family. For addressing different types of application, we offer the most optimal human models on the market with detailed inner organs such as bones, muscles, nerves, and so forth, so on. So you will get a really accurate description of bodies and tissues in the bodies. And, for talking about some practical parameters that we can always find even in our daily life, when you buy a mobile and you read the manual, you will always find this magic number, SAR, specific absorption rate, which is a well-established way to assess the safety of humans from electromagnetic systems. Okay. Typically, a certain mass is used for averaging the power losses in the tissues. For example, 1 gram or 10 grams. The SAR values are averaged over a cubic volume and set in relation to the material density. So here you can see the importance of having the right solution, because the problem is quite complex. We need the right source, the right antenna modeling, the right body shape modeling, the right material and tissues description in order to get the right answer at the end in terms of specific absorption rate. In this slide, just for give you an example, we can see the level of SAR on a human model for an MRI system. As we can see, the highest local SAR is located in the left arm, and limits for extremities are 20 watt over kilogram. Of further interest, as you can see, is that the SAR distribution is not the only final output that we can get, but from SAR distribution, we can get also the temperature distribution. And for that, we use the bioheat solver that includes the effect of metabolic heating and blood perfusion, which can be a non-linear function of temperature. Okay, so the final result that we get is also the heating effect on the body due to the radio frequency radiation that is heating on the body. Okay, and this takes me to the end of this presentation and to the summary. From what we have seen today, basically SIMULIA CST Studio Suite offers a complete state-of-the-art technology, already widely used and very well established all around the world by industries, institutions, and universities. Okay, CST is a standard tool all around the world that everybody will recognize and recommend. Is the perfect solution for problems like antenna design and matching, pattern optimization, array antennas, antenna placement, coverage, electromagnetic interference, biological effects, and SAR, electromagnetic, thermal, and mechanical coupled simulations. And the very good news is that all those capabilities and functions are included into the same package, except for Antenna Magus, that is a separate tool, but except for that, all the results, all the capabilities, all the features that you have seen today are actually included into the same package that is SIMULIA CST Studio Suite. And I have completed my presentation. Thank you very much for your attention. I would like maybe to leave a little bit of space to questions if there are any. Please don't hesitate.
Thank you so much, Rafael, for your presentation. You did a great presentation. I have a couple of questions here. Rafael, let me read the question. 1 minute. First question is, during the presentation, we have seen several models of platform, such as satellite and aircraft. Is it possible in CST Studio Suite to import CAD models, and how much effort is it required to create a good mesh?
I see. Thanks for the question. That's a very nice point, a very important question. So in CST Studio Suite, of course, there is a dedicated modeler. So we have dedicated modeling capabilities. We can build our own model without any problems, easy and straightforward. However, as you can imagine, when it comes to handle complex platforms like aircraft, drones, satellites, we usually have the geometrical description in a CAD format, and CST is fully compatible with any of the CAD formats on the market, whether it's CATIA, SolidWorks, STEP, AGES, and so far so on. We basically have no limitation on that. So from the import perspective, it's easy and straightforward. The other important point is, of course, the meshing side. The mesh, it's very important, and one of our strengths that saves a lot of money, and because it saves a lot of manpower, is the very robust meshing algorithm. Especially for time domain solver, I've never seen a model meshing operation failing. So very easy, just import the CAD model, calculate the mesh for, especially for FIT, TLM, so time domain solver, straightforward, run the simulation, get your results, job done. Thank you very much for this question. It was very nice point. Gave me the chance to highlight this very important point.
Thank you, Rafael. Thank you. We are on time. Voy a cerrar. Muchas gracias a todos los que participaron. No se olviden que vamos a enviar a todos los asistentes, vamos a enviar grabado esta presentación. Quedamos totalmente disponibles los que estamos acá como presentadores para recibir preguntas posteriores y además los vamos a contactar, obviamente, para hacer un seguimiento en algún punto que ustedes encuentren que podamos avanzar o que sea relevante para el negocio de ustedes. Así que estamos justo en el tiempo. Les agradezco nuevamente que se hayan conectado con nosotros. Agradezco también a Solaer Ingeniería, a Ricardo Ramos, y también agradezco a Rafael Escuderi su presentación. La verdad es que fue un buen momento y quedamos totalmente disponibles para preguntas o consultas posteriores. Yo por mi lado me despido y que tengan una muy buena semana. Thank you so much, Rafael. If you want to do some words, welcome.
Well, yeah, no, thank you very much. Thanks, Christian. Thanks, Ricardo. Thanks.